Hi, I'm Zeke Kossover, an educator in the Exploratorium's Teacher Institute, where I'm going to show you some interesting things that you can do with our science snack, Eclipses of the ring light, where we'll show you how a ring light can be a stand-in for the sun. You'll need a small ring light, a bamboo skewer, black construction paper or cardstock, scissors, tape, black marker, a hole punch, white pieces of paper, and a smartphone with a front-facing camera. With these materials, I made a moon on a stick. To represent you looking at the eclipse, I punched a hole in a card so that the camera can see through and drew a little stick figure. You may have seen maps that show the path of totality during a solar eclipse and the area around it that is marked as a partial eclipse instead, and wondered why that happens. To represent the sun, we'll use a ring light. Let's place our disk between the ring light and the white paper. You can see that if the disk were close to the paper, it casts a large dark shadow called the umbra. But as the disk gets farther from the paper, you see that another shadow starts to develop next to the umbra that is not as dark. This shadow is called the penumbra. During a solar eclipse, the sun, moon, and earth are arranged so that the moon casts a small, dark umbra shadow on the earth with a penumbra around it. And if you're in the umbra, you get a total eclipse, and in the penumbra, then only a partial eclipse. Let's see what this might look like from your point of view. We'll use the front-facing, that is the selfie camera, on your phone to represent your eye. Let's put the stick figure picture of you with a hole punched in it for your eye over the camera to make it super obvious. Now, the real sun isn't a ring, I know, but this will be close enough. As the person starts to be in the penumbra, you can see that the sun is being partially blocked by the moon. As the moon gets closer to covering the whole sun, the shadow gets darker. Eventually, the moon can block the whole sun, and the person is in the umbra and is experiencing a total eclipse. If the path of the moon's shadow moves differently, then the umbra may never ever move over you, in which case you'll never experience totality. In some solar eclipses, the moon is a bit farther away from the Earth, and so there's never a dark umbra. These eclipses are called annular eclipses, not named because they happen every year, but because they leave a ring of sunlight behind, which mathematicians call an annulus. So I hope you found this a fun and hands-on way to get a better understanding of what causes umbras and penumbras and total, partial, and annular eclipses.